You need to get good at interpreting the output of the show MAC address table command. But to make it more fun, I've created this ad hoc lab that's basically a puzzle. I think you'll really enjoy this one. Let's jump in. Let me walk you through the lab instructions. Don't open the packet tracer file yet, but when you do, you'll see 3 switches. They're pre-configured. We've got 6 PCs. They're pre-configured, but I don't want you to use any packet tracer features to find out information about them. That's why I don't want you to open the packet tracer file yet. So here are the instructions. I want you to discover the MAC addresses of the PCs without using the easy way to learn that from packet tracer, all right? That kind of gives away the easy answer, if you will. I want you to find all switch interface IDs or port IDs shown in the figure. So if you see an interface in the drawing, tell me what the interface ID is. But there are some restrictions of what you can and can't do to find those facts, all right? So let's look at those restrictions. First off, the goal of this lab is to get you to practice the show MAC address table command. So use that command from the command line interface of switch 1, switch 2, and switch 3. So you'll use the command line interface there. You can use the show interfaces status command, which tells you the status of the interfaces and a brief bit of output per interface. Do not use show interfaces without the status keyword. That gives lots of detail, including MAC addresses of interfaces on the switches. I don't want you to use that one. So show MAC address table, show interfaces status, and then in config mode, you can use shutdown and no shutdown. Shutdown disables the interface, no shutdown brings it back up. That has an influence on what is and isn't in the MAC table, and that will help you figure out which MAC addresses are where in the topology. All right, so those are the main restrictions. Additionally, you can use this ping command on the 6 PCs. So what is that? That's a ping command for the subnet broadcast address for the subnet of the addresses that I've pre-configured for this lab. Now, you probably haven't learned much about what that means yet if you're following along with the books and these videos in sequence, but here's the deal. If you go to A, B, C, D, E, or F, open up a command prompt and issue this command, it will create and fill up most of the MAC table entries on those 3 switches, and that's good for troubleshooting, all right? And then last comment about restrictions, you are allowed to move around in different modes, like enable to move from user mode to privilege mode, configure terminal to move from privilege mode into config mode, so you can move around in different modes. Now, I told you I don't want you to get any help from packet tracer, so let's talk about that. First off, do not hover over the PC icons because packet tracer will pop up a window and will tell you facts like the MAC address. Try to avoid pointing your mouse pointer at the PCs once you open the packet tracer file. It'll make the lab more enjoyable for you. It'll make it more like a puzzle. But you can do this. You can hover over the switches and then click and open up the new window and then click the CLI tab so that you can get to the console of the 3 switches so you can issue commands like show MAC address table. Another don't. Don't use packet tracer settings that reveal the switch interface IDs. So with default settings, when you open up this packet tracer file, it will display the interface IDs of all these switch interfaces. We want to turn that off before you open the packet tracer file. And the next bit of this video will show you how to turn that feature off. So again, we make the puzzle a more meaningful lab exercise for you. Final, don't open that packet tracer file yet until you watch the next 2 minutes or so of video. So let's go do that. So I've got a packet tracer file open that has the same basic topology as your lab, but it uses different interface IDs and different MAC addresses. So I'm not spoiling anything for you there. But right now I've got the settings so that if I hover over a cable, packet tracer shows me the interface IDs. Notice that. I hover over this cable and I see some interface IDs pop up. Hover over this one, I see interface IDs. So you want to turn off that setting that makes those show up before you open the packet tracer file for lab. And you can do that with packet tracer preferences. In that box, it's the one I've checked over here that I'm pointing at, show port labels when mouse over in logical workspace. So I could uncheck that and that effect wouldn't happen. But the default setting, which you may still be using, is this one over on the left-hand column. It says always show port labels in logical workspace. And if I click it, it'll automatically go ahead and start showing those on the left. See, now we see all the port labels showing up. And if you already see that kind of thing, you definitely want to turn that off because it would automatically show them and kind of spoil the lab. All right, so you'd want to go into packet tracer preferences or settings and make sure to uncheck always show port labels and uncheck the show port labels when mouse over, and then you won't have that effect. While I'm here, I'll just show you don't hover over the PCs, because when you do, you get this pop-up window. If you look at the far right, you see the MAC address appearing there again. That's not the MAC address you'll be using in lab, but avoid that as well. So now you're dangerous. I'll give you a few seconds to hit pause and now go do the lab. As a quick reminder, use show MAC address table, use show interfaces status, use shutdown and no shutdown in config mode. You can use this ping command of the subnet broadcast address from the PCs. And finally, you can move around in different modes. Those are the only things you should do. Go ahead and hit pause and get in there and do the lab. So at this point, in my analysis, we don't know anything yet. We don't know any of the MAC addresses, and we don't know any of the interface IDs. So let me walk you through the command line interface to show you how to discover some facts about switch SW1 and host A and B. So if you looked in the description in this video and downloaded the packet tracer file and opened it, you'll see a topology like this. We're going to start by focusing on switch SW1. So if we click it, click the CLI tab, we'll see something like this. If you click inside the window and press enter, you should see a new line each time you press enter. Then of course we want the show MAC address table command because that's the focus of the lab. So if we look at it, we already see one entry in the MAC table. Why? Well, it turns out in packet tracer by default, the PCs don't send any overhead traffic. So the switch hasn't learned any of the PCs MAC addresses. But the switches themselves send some overhead messages, say like for spanning tree. So each switch learns of the neighboring switch's MAC address. So here we see this command that we issued on switch SW1. It says port gig 109. So there's a MAC address that switch 1 learned on its gig 109 port. So this right-hand port would be gig 109 as it turns out. And there's the MAC address of the neighboring switch, for instance. But I'm going to focus on the PCs, and I'm going to quickly not hover and click on click on desktop and command prompt so I can issue that broadcast ping and generate some traffic. So it generates traffic that's sent by A, and it will also cause the other 5 Ps to send back a message. So it's going to fill up switch 1's MAC table with the MAC addresses of all 6 of the PCs. So ping 172.16.9.255, and we see replies from all 5 of the PCs. And it's going to keep running for a moment. And the Control C may or may not work depending on how packet tracer is behaving today. So we'll just let that run, and we'll go back to switch SW1 and repeat the show MAC address table command. And now we've got a nice full table. So how do we know which ports on switch 1 are connected to A and B? Well, those ports should show 1 and only 1 MAC. Whereas if you look at the figure, this port on the right, it should have C's MAC and D's and E's and F's MAC all associated with this right-hand port on switch 1, right? So if I click on switch 1 and get back to the CLI, we see port gig 109 has a bunch of MAC table entries. So that's confirmation that that right-hand port on switch 1 is the one connected over to the right. And the ones here that have a single MAC address connected to them, that's confirmation that those are the ones hooked up to A and B. However, we don't know which one is hooked up to A and which one is hooked up to B. So how do we figure that out? Well, we've got these 2 ports that are hooked up, or at least the MAC address table shows only 1 MAC associated with them. We can shut one of them down and see if that ping still works, all right? So let's pick gig 102 here and get into config mode. And int gig 102 and issue the shutdown command to disable the port. So now, if that's hooked up to A, that ping on A should no longer work. And if it's hooked up to B, the equivalent ping over on B should no longer work. So if I click over at A, that ping command has stopped working. I'm going to up arrow to retrieve it. Let's see if that still works on A. And it looks like it's still working on A. We're still getting replies from 4 instead of 5 PCs. Why not 5? Well, one of their ports, specifically host B, just got shut down, right? So if I open a command prompt on B and I issue that same subnet broadcast ping, we're not getting any replies, all right? So that's another confirmation that B's not able to function right now. All right, so that's a confirmation, if we go back to switch 1, that when we shut down this port gig 102, we brought it to administratively down. That's the port hooked up to host B. So we could fill in the rest of our notes about what interfaces are what by knowing that gig 102 is connected to host B. Host B's MAC address is this one that repeats 0197 in the middle and right. And that port gig 1023, by implication, is hooked up to host A with this MAC address. So now that we've done that demo and analysis, what do we know? Well, we talked about the fact that the right-hand port is port gig 109. The one we shut down, gig 102, is connected to host B. And gig 1023, the one we didn't shut down, is connected to host A. And just for reference, the MAC addresses, A was the one that had the repeating 0199 in the MAC address, and B was the one that had the repeating 0197 in the MAC address. Now we're moving the analysis to switch SW2. So we know the interface IDs on switch 1, and we know the pattern that you'll see in the MAC addresses on hosts A and B. We're going to do the same thing here for switch 2 with 4 interfaces and 2 PCs. So now let's focus on switch 2. We want to figure out the interface IDs of the 4 interfaces in the figure on switch 2, as well as the MAC addresses of C and D. So you could go ahead and get into the command line interface on switch 2 and click in the middle, and I just habitually like to get into privilege mode. Show MAC address table, and we see 1 MAC address so far, and we're not really sure which one that is yet. Now there is overhead traffic in the network, so if I up arrow and hit enter again, from my experience with Packet Tracer, I know both of those neighboring switches are sending overhead traffic, so the PCs aren't. So switch 2 should hear from both of those neighboring switches and learn about them and learn their MAC addresses, all right? So one of those MAC addresses is switch 1's MAC on its right-hand interface, and one of those is switch 3's MAC on its left-hand interface. And if you look back at switch 2's CLI, the interfaces are gig 106 and 1021, but we don't know which yet. So we're gonna figure that out before we're done here. So next, let's fill up the MAC table with the PC MAC addresses. So I've already opened up the desktop tab, and I'm going to issue that broadcast ping again. It's just a nice, easy way to fill up the MAC table for testing. And we did that subnet broadcast ping. We're getting 5 replies back, so that's a good sign. We're filling up the MAC table. So if I go back over to switch 2, let's take a look at what we see now. And it's nice and full. Let's reflect a little bit. We'll focus first on what we see on the neighboring switches. So look here, we've got a couple of interfaces with only 1 MAC address listed off of the interface. I figured that out just by scanning the list of ports in that right-hand column. Whereas we've got 1, 2, and 3 MAC table entries off port 106, and 1, 2, 3 entries off port 1021. So thinking about the topology, I see the fact that I know 3 MACs off 2 different interfaces. I think of them as say, hey, that's the MAC of A, B, and switch 1 on one side, and E, F, and switch 3 on the other. But which is which? Which are reachable out which port? So if I remember the MAC addresses we just looked at, remember we saw the repeating pattern 0199 and 0197 on host A and B, respectively. Well, they're reachable from switch 2 off its port gig 106. So that's the logic I would use to say that this left-hand interface is gig 106. And then the fact that 3 MAC addresses are reachable on switch 2's port gig 1021, I would decide that this right-hand port on switch 2 is gig 1021. So that's how I would go about figuring out the left-hand and right-hand ports on switch 2. We also have the same old problem of which port is C on and which port is D on. If we look at the MAC address table some more, remember we've got this port gig 103 with one known MAC address, this port gig 1017 with one known MAC address. So which one's connected to C and which is connected to D? Well, we can follow that same process we did before by clicking on C and repeating that ping command, but first, let's shut down one of the ports. So, I don't know, gig 103, it's the lower numbered one. So let's just do that. So config T, int gig 103, and we'll do a shutdown and shut down that port. So either C or D, one or the other, its pings should now fail. So if we go back up to C again and do an up arrow to retrieve the command and try it, well, C is still working. All right, if we go over to D, which we haven't tried yet, get into desktop, command prompt, and issue that ping, it's going to fail. I'm confident of that, but the reason it's failing is that port is shut down. If we go back to switch 2, which we're still in interface config mode, and do a no shutdown, just for fun, that port will come back up. And if we go back and check port, the ping command on D, it should be working again here in just a moment. But what does that do for us on the MAC table? It just confirms the port we shut down, gig 103. See, it's even gone from the table now, right? It's not listed anymore, but if we go back to host D and reissue that ping command, it's going to generate some traffic. We come back to switch 2. There it is. It's relearned again. So that's another confirmation that that port gig 103 is hooked up to host D. This MAC address that has repeating 0191 would be host D's MAC address. And the other single MAC address listed port, gig 1017, that's the one that's hooked up to host C. So again, in our puzzle of filling in all the interface IDs and MAC addresses, we've identified both C and D's ports and their MACs. So what did we learn on switch 2? Well, first off, we learned that the 2 PCs, gig 103 that we shut down is the one that stopped host D from working. So that's connected to host D. Gig 1017 then is connected to host C. Then we saw 3 MACs each on the left and right hand interface. We figured out that gig 106 was connected over to the left because we saw those familiar host A and B MAC addresses. And then by implication, gig 1021 must be the port that's connected over to those MAC addresses that we really hadn't focused on yet. Then for the specific MAC addresses, the MAC addresses we saw off those 2 ports that had a single MAC address, those are the ones that saw the repeating pattern 0193 and 0191 for your reference. Now let's repeat the same thing over here on switch 3. We'll find the interface IDs and MAC addresses of those 2 attached PCs. Next, we'll focus on switch SW3. The lab's beginning to get a little bit repetitive, which is important that you get comfortable so it feels repetitive, right? But here we go. I'm going to click on switch W3. I'm already in enable mode there. Show MAC address table. And we just see one MAC address. That's the neighboring switch, SW2. And I'm going to get into host E and get to a command prompt and issue that subnet broadcast ping again, ping 172.16.9.255, and get 5 responses back, and get back over to switch 3's console and look at the MAC table again. And now it's nice and full. We've got 7 entries, one for the neighboring switch's MAC address. We don't learn switch 1's MAC address. It's only the neighboring switch whose MAC address you'll learn. And then the 2 attached PCs will learn, and then those other 4 PCs, but those other 4 PCs, the port will be through this one port on the left side of switch W3, topologically speaking. So one of these ports, gig 1013, it's going to have 1, 2, 3, 4, and 5 MACs listed for this topology. whereas the two ports that are connected only to hosts E and F will have that single MAC address. So it's the same kind of logic that we've been talking through already. All right, so that confirms that port gig 1013 is the port on the left-hand side of switch SW3. Then we've just got the question of which of these two ports is connected to E and which is connected to F. And by the way, there are their MAC addresses repeating 0181 and repeating 0179 in there as well. So this time, just to be complete, let me shut down a port. We'll do 1011 this time. We'll shut it down and we'll go back to host E and repeat that broadcast ping command. And it turns out this time on host E, it looks like the ping is not working. So that's a confirmation then that this shutdown of port gig 1011, we shut down the port connected to host E, 1011. So that'd be host E's MAC address, and 105 presumably still working over here would be host F's MAC address. So what did we learn here? Well, we learned about E and F and the shutdown port gig 1011. When we shut it down, E's ping quit working, so we confirm that's the port connected to E. And by implication, gig 105 with a single MAC listed on it is the port connected to PCF. The port that was connected that showed 5 known MAC addresses off of it, gig 1013, that's the port on the left of switch 3. And then we saw the MAC addresses for E and F that had repeating patterns of 0181 and 0179 off of E and F respectively. Do you want more about this topic? Well, there's an instructional video that goes along with this Show MAC Address Table Focus, so click on the left to learn more background about this topic. Then if you want the next topic, click on the right and learn about how switches automatically manage the MAC table as the entries age, as well as how you can manage it manually with the clear command. Hey, thanks for hanging out. I'll talk to you soon.